Okay, these notes are concept number 11, which is your least common multiple, or we can abbreviate it as LCM. With this, you are trying to figure out what is going to be the smallest common multiple between a set of values, okay, or a set of variables. So least in this case means the smallest. So if you're given multiple numbers, so I'm given 2 and 7, okay, multiples of 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 4 is, or 2 times 5 is 10, 2 times 6 is 12, and so on, okay? Multiples of 7 means I'm multiplying something times 7. We go right in order. 7 times 1 is 7, 7 times 2 is 14, times 3, times 4, times 5, and so on, okay? That's what multiples are, is listing them out in the order that you would multiply them. So for this first example, it's just listing the multiples. Right? List the first 5 multiples of 8. So 8 times 1 gives you 8. 8 times 2 is 16. Times 3 is 24. Times 4 is 32. Times 5 is 40. That's if you're just asked to list the multiples. Now, in this case, we're going to start into finding the least common multiple between two different numbers. So in the first example, we're looking at 4 and 6. Right, so I'm going to find the least common multiple between the both of them. That means I want the smallest multiple that is common to both. So multiples of 4, list those out first. 4, 8, 12, 16, 20, and you can keep going as far as you need to. I would only do 4 or 5 at a time, and then do 4 or 5 of your other value so you can see if anything matches up. Then when you do 6, multiples of 6 are 6, 12, 18, and 24. So we already have a matching multiple. Right? That's the smallest matching multiple that we have. So the LCM is 12. Between 5 and 12. So list out your multiples of both, 5, 10, 15, 20, 25, and so on. And then listing the multiples of 12. In the 12s, you only have to list it now as far as you need to go to find a matching multiple. Okay, in this case, when you start listing your multiples of 12, you're going to find it pretty quickly that your LCM, the smallest common multiple, is 60. Now, once we get into monomials, so those examples were just constants that you were finding the LCM of. Now we're going to get into some monomials. The beginning portion of it is the same. You need to find the LCM of your constant first, of your coefficient. So in this case, I need to find the LCM of 8 and 6 in order to start the problem. So that part's exactly the same. We're going to list out the multiples of each until we find the first multiple that is common to both, that they share. Okay, so in this case, between 8 and 6, their smallest common multiple is going to be 24. Then because we had variables here, we have to then include that. Okay, so you're going to compare their variables. Now, the only variable that we have here is an x. Okay, so in my first monomial, I had an x squared. In my second monomial, I had just an x to the first power. So because there's an x that shows up, there has to be some sort of an x value in our final answer. We just have to figure out which exponent to choose. With LCM, you are always choosing the larger exponent. So because I had an x squared and an x, I am choosing the larger of the two, which is the x squared. So that's what's going to be with my final answer. So I'm just going to combine them. The LCM from my coefficients was 24. The LCM from my variable was x squared. So now I combine them. My total LCM is 24x squared. In this next example, we still have monomials. They're a little bit larger this time, but it's the same process. Start with just your coefficients, so the 12 and the 15. Listing out the multiples of 12, we have 12, 24, 36, 48, and 60, right? And we could keep going as long as we needed to, but we stopped there because multiples of 15, 30, 45, and 60. So 60 is the smallest common multiple, okay? So that is going to be part of our answer. Now I have to look at the variable portion of this. Okay? I have two different variables that are happening here. I have an a term and I have a b term. So we're going to compare them. I have an a to the third from my first monomial, and I have an a to the first power from the second monomial. Okay? Again, you're always choosing the larger exponent. So between the two, a to the third is obviously larger, so that's going to be part of my answer. Then I look at my b variables. I have a b to the second and a b to the fourth. So again, I am pulling out the larger of the two, which is the b to the fourth. Okay, so your final answer when we combine all of that together is 60, a to the third, b to the fourth. All right, last example, same basic concept. Now I have three monomials that I'm comparing. It's the same process though. Okay, it doesn't matter how many you're comparing, it's still the same process. Start with your coefficient. So we have a 2 from our first monomial, we have a 3 from our second monomial, and we have an 8 from our third monomial. So I need to find the smallest common multiple from all three of them now. Okay, the smallest common multiple that we find is 24. Then we're going to look at the variables. Okay. Again, we have multiple variables happening. I have x's and y's that show up in these terms. So I'm going to start with the alphabetical order. We're going to start with x's first. So I have an x to the fourth. I have no x's here, and I have an x squared. Okay, so the highest power that I have for my x's is the x to the fourth. So that is going to be attached in my answer. Then I compare the y's. I have a y to the first, a y to the second, and another y to the second. So the highest power that we have is a 2. So it's a 24, x to the fourth, y to the second power. So you just have to remember that even though it's called least common multiple, when it comes to the variables, you are finding the greatest power, the highest power. Other than that, the coefficients, you're just listing out the multiples and finding the smallest one that is common to all of your terms. So again, this was your concept number 11, which is least common multiple.